projects. In this video, we are going to explain about the project, which is brain tumor classification using hybrid single image super resolution technique with Resne and VGG19 pre-trained models. Coming to the introduction, the diagnosis and classification of brain tumors are critical tasks in the field of medicine, given the inherent heterogeneity of tumor cells. Physicians play a pivotal role in this process, but the complexity of the brain tumor calls for advanced diagnostic tools to aid in rapid and accurate diagnosis. Modern diagnostic systems leverage computer-aided technology to effectively diagnose brain tumors using magnetic resonance imaging, which is MRI. MRI is the preferred technique due to its high quality of imaging, making it a primary choice for brain tumor classification. Artificial intelligence is emerging as a vital tool to address these challenges associated with brain tumor classification. High-performance deep learning models have the potential to significantly enhance the accuracy and the speed of brain tumor detection and diagnosis. While machine learning and deep learning models are being employed to classify and diagnose brain tumors, existing models face limitations in the term of accuracy. Deep convolutional neural networks, while effective, require extensive training time. This project focuses on the implementation of transfer learning models, specifically Resne and VGG19, to improve the accuracy of brain tumor detection and classification. These models are known for their architectural simplicity, reducing computational cost and training time. The study utilizes a dataset available on Kaggle and employs data augmentation techniques to address the scarcity of medical images, addressing a significant challenge in brain tumor classification. Objective of the project. The objective of the project is to develop a brain tumor classification system using deep learning models and a single image super resolution technique, which is SSIR. The project aims to utilize high-quality medical images to aid the diagnosis and detection of brain tumors, overcoming the cost and time issues associated with traditional diagnostic methods. The specific objectives include implementing robust Resne and VGG19 models to classify two types of brain tumors, which are pituitary and glioma. The models are trained using a dataset of MRI images, and they are optimized with hyperparameter tuning and data augmentation techniques. The SISR technique is applied to enhance the basic features of the MRI images, improving the performance of the models. The ultimate goal is to provide a quick and accurate approach to distinguish between patients with pituitary and glioma tumors, assisting doctors and radiologists in the screening process. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this module, we import the necessary Python packages and libraries that are required for the project. We have imported NumPy for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for data visualizations, Scikit-learn for machine learning. Coming to exploring the dataset, this module involves the exploration and the loading of the brain tumor dataset. The dataset used in the project comprises a collection of brain MRI images obtained from diverse sources including medical institutions. These images are labeled to indicate the presence of brain tumor and their specific types. Here we typically load and examine the dataset to understand its structure, size, and the types of data it contains, such as MRI images and associated labels. Coming to single image super resolution using pre-trained GAN PyTorch. This section focuses on using PyTorch and a pre-trained GAN, which is Generative Adversarial Network Model for Single Image Super Resolution, which is SISR. This process includes creating and using residual blocks, loading a pre-trained model, processing low-resolution images into high-resolution images, which are HR images, and saving those HR images. Coming to exploring the saved dataset of HR images, after applying SISR, this module involves exploring and examining the saved high-resolution images to ensure the quality and effectiveness of super resolution process. Coming to image processing, This section typically involves using an image data generator for data augmentation and processing. It includes tasks like image rescaling, shear transformations, zooming, horizontal flipping, and reshaping. Data augmentation is a common practice to increase the diversity of training dataset. Coming to building the model. In this module, various deep learning models are created for image classification, including Resne 101 and VGG90. These models are crucial for classifying brain tumor images. Coming to the trained model, this step involves feeding the training data into the chosen deep learning model, optimizing the models using backpropagation, and iteratively improving their performance through training epochs. Coming to dumping the model, once the models are trained and achieved satisfactory accuracy, they are saved or dumped for later use. This ensures that the trained models can be reused without retraining. As an extension, we build transfer learning model for improving accuracy, and also as an extension, we build the front end using the Flask framework for user testing with the user authentication. Flask framework with SQLite for sign up and sign in. In this section, a web application is built using Flask framework and SQLite is used as a database for user registration and authentication. Coming to user upload and image for analysis. Users can upload an image that they want to analyze. The uploaded image is then processed and prepared for analysis. The given input is pre-processed. The uploaded image is pre-processed as needed for chosen image classification model. This could include resizing, normalization, or any other necessary transformations. The trained model is used for predicting the result. The pre-processed image is input into the trained deep learning model to predict whether the image contains a brain tumor. If so, it will predict the type of tumor. Coming to the last module, which is final outcome, is displayed through frontend. The prediction result, such as the classification of the brain tumor, is displayed to the user. This outcome is usually presented on the web interface along with the relevant information or instructions. Algorithms used in this project are Resne 101. It is a deep convolutional neural network architecture that is the part of the ResNet family. It is characterized by its deep structure with 101 weight layers. The core idea behind ResNet is to use residual blocks which contain skip connections to allow the network to learn residual functions. This mitigates the vanishing gradient problem, enabling the training of very deep networks. ResNet 101 is used in image classification tasks including medical image analysis, due to its ability to learn intricate features and patterns from complex images. The next algorithm that we have used is VGG90. It is another convolutional neural network architecture that is part of VGG family, developed by Visually Geometric Group at the University of Oxford. It is known for its simplicity and uniform architecture comprising of 19 weight layers. VGG networks are characterized by the repeated use of 3x3 convolutional filters and max pooling layers, resulting in deep feature learning. VGG19 is often used for image classification, feature extraction, and transfer learning tasks. It is employed in various applications including medical image analysis, where it can effectively extract features from medical images for tasks like tumor detection and classification. As an extension, we have built transfer learning model to improve the accuracy. So here we have comparison graphs. This is the accuracy comparison graph. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. So in this graph, we can observe that x-axis represents accuracy score and y-axis represent algorithm names. This is the precision score comparison graph. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. So in this graph, we can observe that x-axis represents precision score of each algorithm and y-axis represents each algorithm name. This is the recall score graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. So this graph also represents on x-axis recall score of each algorithm, and here we have algorithm names. And here we have F1 score graph. F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. So here we can observe that x-axis represents F1 score of each algorithm and y-axis represents algorithm names. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. And this is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path from the code folder of the address bar. So I'm copying the path, and now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folder directory. Here we need to type the command which is python space app.py. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. Now we need to copy this local link provided by the framework and paste it in any browser. I prefer Google Chrome, so I'll paste it in that. So here we need to paste the link, and at the end we need to type enter. We can see that web page of the project is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a link which is sign up link, so we need to click on that. So I'm clicking on it. Here we need to enter all the sign up details if we are signing up newly. I have already signed up, so I'll directly click on sign in. Here we need to give our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on sign in. So we are redirected to home page where we need to upload the images. So I'm clicking on choose file to upload brain tumor image. From this list, we need to select any image. So I'm selecting this image and click on open. And now we need to click on upload. So based on the given input image, it is predicted that the patient is suffering from pituitary tumor. Now we will upload one more image. So for uploading one more image, I'm clicking on choose file. And this time I'll select this image and click on open. And now we need to click on upload. So it is predicted that the person is suffering from pituitary tumor. Now we will upload one more image. So I'm clicking on choose file to upload the image. I'm selecting this image and click on open. And now we need to click on upload. So it is predicted that based on the given image, the patient is suffering from glioma tumor. Now we will upload one more image. So I'm selecting this image and clicking on open. So based on the given input, it is predicted that the person is suffering from glioma tumor. In this way, if we give the brain tumor images, the system will predict which type of tumor it is. Now we will sign out. Conclusion of the project is the implementation of robust Resne and VGG19 models along with hyperparameter optimization successfully achieved substantially greater test accuracy for a graphics processing unit. The application of a single image super resolution technique based on generative adversarial network algorithm improved the resolution of MRI images, enhancing the performance of the models. The project's primary contribution includes the implementation of these models for fast and accurate diagnosis of glioma and pituitary brain tumor cases, which could aid doctors and radiologists in the screening of the process. The results obtained from the experiments demonstrate the potential of the proposed model to provide a quick and accurate approach for distinguishing between patients with pituitary and glioma tumors.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.